Okay, this is assignment 2.1.9.1, basically the ultrasonic sensor, learning how to use the ultrasonic sensor to measure distance to an object. And basically the way the ultrasonic sensor works is like a sonar. It's going to measure the distance to an object based on this reflection of sound back to it. So just like a bat works, bats use ultrasonic sound basically to measure distance to their to objects and to kind of figure out what the environment around them is. That's the way the ultrasonic sound sensor works also. So basically this bat sends out a sound, a high frequency vocalization basically, and then it listens for that vocalization to come back to it, and then based on the distance, based on how long the echo took to come back, it can kind of build a picture in its brain of the environment around it. The ultrasonic sensor kind of works the same way. Basically, what would they do? What you do with the ultrasonic sensor? Basically, we send out a ping or a high frequency sound pulse, and then we measure the time between the ping and how long the echo takes to get back, and then that gives us a distance. Basically gives us a calculation for the distance to the object. All right, and then this is a video here that you can watch on how sound works in general, and kind of get a little feel for that kind of thing. All right, now for our project here, we're going to be using the ultrasonic distance sensor to kind of measure distance to things basically, and we're going to use some LEDs to kind of light up to light based on how close or how far away something is. So again, the closer it is, the more LEDs light up, and then the further away, the less LEDs, and then basically you should be able to figure out distance to things based on how many LEDs you're lighting. So for our parts, we're going to need the Arduino, of course. We're going to need a breadboard. We're going to need the ultrasonic distance sensor. We're going to use 4 LEDs. And then we need 4 330 ohm resistors to go with those LEDs, and then we're going to need 9 jumper wires. All right, so then we're going to get this set up in our virtual circuit. We're going to do that next. Okay, so we're going to use again our Arduino board and our breadboard. We have to get some other components here, so let's get some LEDs. You can make them red or yellow, it doesn't matter. I want to make mine yellow. So I need 4 of those. So 4 LEDs, make them yellow. I need some resistors. Again, my resistors need to be 330 ohm resistors. I wish there was a way to copy these guys, but unfortunately the editor doesn't let you do that. So I just have to pull them out and adjust them as we do it. Okay, so we need those, and then we need a ultrasonic sensor. So I'll just start typing ultrasonic. There we are, ultrasonic distance sensor. All right, now this ultrasonic distance sensor that we'll be using for the virtual circuit is not like the one we'll be using in our actual circuit. So I'm going to move stuff over here a little bit so I have some room. But basically, it'll work kind of the same way, so just not exactly the same way. So, but anyway, let's start getting stuff hooked up here. So I'm going to rotate these guys first. All right, and then our resistor, of course, goes into our negative channel of our breadboard here. So I'm going to put it right there in the negative channel. And then our LED, the shorter leg, is going to be hooked up to that. Okay. So let's get the rest of these in there. So put another one there. Whoops, there. And then rotate this one. That one in there. And let's see. Oop, get that one in there. And one more. There we go. And last one. Okay, so those are our LEDs hooked up. again, we're going to hook up the legs to the Arduino board here in a second, but I'm going to put in the ultrasonic sound sensor here, so I'm going to rotate that. And again, just put that on any of these kind of sections here. And that should work there. All right, so let's start getting everything else hooked up. Let's start hooking up our voltage here. Bring that over. Line that up. Make that red. And our ground. Coming over. Okay, so let's line that up a little bit better there. Okay. All right, so our ground and our voltage is hooked up. Now again, we're going to run the other leg of our LEDs over to our digital pins here. So I'm just going to start running those over. Come down here, put that one in 2. Give it a different color. Say turquoise. Gonna run this one out here, coming down here, run that one into 3. Give that one the next one. Again, line these up. Purple. And last but not least, gonna bring this one down here. Bring that into 5. Alright. And then make that one a pink. All right, so again, we get our LEDs hooked up here. Wait a minute, this one here needs to be, this one here is not right. I can see already. All right, so there we go. Yeah, double check to make sure your connections are all in the right spots and so forth for your things. All right, so the ground pin for your ultrasonic sensor, of course, goes into the ground for the Arduino board. Let's make that one black. The 5 volts is going to go directly into our 5 volts, which will be easy. Make that one red. And then our signal pin here is going to go to digital pin 7. Kind of just bring that over here to 7. Kind of line that up a little bit. All right, and then you guys, can make that anything. I'm just going to make it gray. All right, so basically for this ultrasonic sensor, basically you just need the signal pin, you need the 5 volts, and you need the ground. So those are pretty simple to set up there. But basically, there you go. That's the setup for our ultrasonic sensor virtual thing here. So, okay, so now it's time to start coding. Again, we're going to remember code's mantra: comment first, code last. All right, we'll start by typing the following comments. Again, a little description of what our program is going to do here. We're going to measure the distance away from the ultrasonic distance sensor and turn on a series of LEDs that give an indication of that distance. And we're going to start by initializing some constant variables for our pins, and so forth. So then in our void setup function, we're going to type in the following comments. We're going to be using a serial monitor again for reading off our distance values. And we also are to make sure that the LEDs are doing what they need to be doing, and we also have to set up the 4 LEDs for output. All right, in our loop function, we're going to basically use the loop to capture the information from the distance sensor and convert that into inches, both inches and centimeters. Then we'll use that information for lighting up our LEDs. Again, we're going to establish variables for a duration of the ping. And the distance that results in the inches and centimeters. Now, because our virtual circuit uses the ping ultrasonic sensor, basically the special ultrasonic sensor that it comes with the Arduino, the virtual Arduino thing here, it only uses 1 pin for sending and receiving. So we're going to type in these comments to kind of explain how that works, basically. So what happens is that we actually send a signal to the pin to trigger a pulse first, and then we wait a couple microseconds, and then we listen for the return pulse, basically, to ensure that we get a good signal coming back. Okay, and then we set the ping pin for output. We clear the ping pin, we delay for 2 seconds, and we send out another ping and delay for 2 seconds, and so forth. All right. Again, since the same pin's used for both, we have to kind of wait for a little bit before we can send or tell if we received anything. So keep that in mind. All right. Then we set the ping pin for input and determine the length of the echo duration. So now, what we're doing for this particular program is we're using what's called a return function. Now, there's a difference between return functions and subroutine that we have been using for our functions. Now, the frequency function in this case basically is going to be what we call a return function, in that it's actually returning a value, so that we can use that to do other kinds of program stuff. Now, that's different than a subroutine, because a subroutine actually takes our program and goes in maybe a different direction, or has it go and do something else before it actually, maybe comes back to the original loop and so forth. So in this case, we're going to be doing we're going to have two different return functions. We're going to have one called microseconds to inches, and then also one called microseconds to centimeters. So basically two different functions to calculate the distance, one in inches and one in centimeters. So don't forget to type these two comments in our loop function too. All right, now so we want to send all this information to our serial monitor, so we want to make sure we do that. So we send the distance data to the serial monitor for verification. And then we're going to wait about 1/10 of a second before we move on to the next thing. Now, we want to light up 4 LEDs based on how close an object is to our sensor. So our different distances are going to be from 0 to 20 centimeters, 21 to 40 centimeters, 41 to 60 centimeters, and 61 to 80 centimeters. And depending on how far that distance is how many LEDs we're going to light up. All right. So we're going to use a series of if statements to kind of get at that kind of information there. So make sure we type in all these comments here before moving on. All right. We want to build in a delay so that our checks capture the moment when we receive our most recent data. So we want to put in about a 1/2 second delay. All right. So then we're going to put in comments for each distance. So a distance greater than 20 centimeters and less than 40 centimeters, a distance greater than 40 and less than 60. And again, we tell how many LEDs we're lighting here. A distance greater than 60, less than 80. And then finally, a distance greater than 80 centimeters, turn off all the LEDs, wait for 1/2 second, so forth. All right. So now we want the two return functions. The first one's called microseconds to inches. So we want to create a function for that. And inside that function, we're going to put in the following comments. Make sure we have these comments in there. All right. We're going to do the same thing for centimeters. So we're going to create another function called microseconds to centimeters for that one. And then again, we're going to put these comments into that function. So those are two return functions that we're going to be using. All right, so now's the time to check our comments, make sure all of our stuff is working correctly, do some trust-driven development before we start actually putting in our code here. Okay, so here we are back at our circuit. We're going to go to the code editor here. We've typed in all the comments, set up all of our functions here. So we just need the setup function and the loop function. Then we have our return functions. And you can see that our return functions are a little bit different coded. In this case, we're using a variable type for this one. This is a long. Long basically allows us to do decimal numbers. So basically allows us to do, give us a little bit more accuracy maybe. And again, the other thing too to keep in mind is that we're sending microseconds to this. So when you do code yours, don't forget to put your functions, when you build these return functions, don't forget to put in the parameter that we're sending to it here. In this case, it's going to be a long variable type, and it's going to be called microseconds. And same thing with this one, we're taking microseconds and we're converting this one to centimeters and this one to inches, but we need microseconds to be sent to these functions. Okay. All right, so if everything works correctly, we should basically see no errors, but basically nothing's going to happen because, again, we're not doing anything yet. So if we start the simulation, as you can see, again, our simulation's running, but nothing's happening, and that's kind of what we expect. Okay, so time to start coding. Again, we'll start with setting up our constant integer variables for our pins. Again, we need a ping pin from our ultrasonic sensor, basically. That's going to be on digital pin 7, and then we need LED pins to control the LEDs. Those will be on digital pins 2, 3, 4, and 5. Okay. Again, we're going to be using our serial monitor to help us to monitor what's going on here. So we're going to start under the void setup, after the comment about setting up the serial monitor. We want to start that with that code there. The next thing we want to do, of course, is set up our LEDs for output. So we want to set the pin mode for each LED to output. Okay. All right. Now in our loop comment, or our loop function, basically, after the comments about setting some variables for duration of the ping and the distance and so forth, these variables are going to be a long type. That allows us to do decimal numbers, so they're not just going to be whole numbers, they're going to be fractions and other kinds of decimal numbers and so forth. So basically we're going to need a duration variable for how long we're going to be, how long before the echo comes back from our ultrasonic signal. We need inches to determine how far in inches our object is away, and also a centimeter one for how long in centimeters it's away. All right, now again, our ping ultrasonic sensor-based device basically uses just a single digital pin to send the ultrasonic pulse and to also receive the returning sound wave. So we trigger that with a high pulse, with the high, again, a digital indicator basically of high pulse for 2 or more microseconds. Then we give it a short low pulse beforehand to ensure that it cleans, so there's no other residual pulse in there basically. So basically in front of the following code, we're going to type each of these comments. So again, the pin mode for the ping pin here is again set for output. So we set that in the loop here. Then we're going to digital write basically. We're going to set it to low first of all. That clears the ping pin, make sure that it's not already making a sound or already listening for something. We want to delay 2 microseconds. Okay, so it's a delay of 2 microseconds. And again, that's a command. Digital write, again, we're going to send out we're going to write to the ping pin. Basically, we're going to send it a high command, basically to send out a ping. We're going to delay another 5 microseconds, basically, and then we're going to send it another low, basically, to stop sending it the high, basically. So, again, we're sending out this ping, and now we're going to, after that, then we're going to wait for, we're going to wait till we hear it back, basically, from the sound, and then that'll give us a duration here. So now we put in the pin mode. We want to change it from output to input. So we change our ping pin basically to input now. And then our duration is basically the pulse in, basically, okay, from the ping pin, and which is high. All right, so basically what we do is we have it set for an input, and then when something comes in, basically, it listens here, basically. And when something comes in, it's listening on the high, for the digital high here. It'll give us a duration here. Basically, it'll kind of calculate for us how long it took to get back that signal. Okay, and we put that into our duration variable here. All right, now we're going to use that duration variable basically to calculate how far the object is away from us in inches, and then also in centimeters. So we're going to use our return function here, microseconds to inches. And again, we're going to send that the parameter, the value of duration here, so that it has something to work with. And also the same thing here for centimeters. We're going to send it the return function here, microseconds to centimeters, and we'll send that the duration one. Okay. All right. Now, the other thing we want to do, though, is we want to basically print off or send to the serial monitor basically how far each of these, how far it is in inches and centimeters. So we're going to print the inches value when it comes back. All right. So let me go back real quick for a second. So what happens here is, let me explain this a little bit more too, is like this return function is going to be a value. So this is actually going to set our inches variable here to a value that is calculated with this function. Okay, so this function is going to take our duration information, and then it's going to send back to us basically a value that we can then put into the inches variable here, and the same thing with centimeters. So that's kind of what's going on there. Now once we have that information, then we can print it into the serial monitor. So we can print inches here, and then we put in there the inch designation, so we know that this number is actually inches. Then we do the same thing with centimeters. We put a little comma and a space here so to separate those a little bit better. And then we put in centimeters, and then we put a print line so that every different line is a different value, basically, or a different set of numbers and so forth. All right, then we want to delay for 1/10 of a second, so we delay for 100. Okay, now we're ready to start coding for our LEDs so that our LEDs can give us an indicator basically of how far an object is from us. All right, so in front of the comment, a distance that is greater than 0 but less than 20 centimeters, basically something that's kind of right in front of the sensor. Basically, we're going to put in the if statement. And again, centimeter is greater than 0. The 2 ampersands here means and. The centimeter is less than or equal to 20. So basically, centimeters greater than 0 but less than or equal to 20. All right, then we're going to do the following things. We're going to want to light all the LEDs because, again, that means it's really close. So we write digital write to LED pin high, 1 high, LED pin 2 high, LED pin 3 high, LED pin 4 high. All right, and then we're going to delay for 1/2 a second. Give me a second for the text to go away there. So again, we're going to delay for 500 milliseconds or 1/2 a second. All right, and then we got to remember to put the ending curly bracket. So we start with a curly bracket here. We put an ending curly bracket here for our if statement. All right, so then we do our next if statement. In this case, it's greater than 20 but less than 40. So again, centimeters greater than 20 and centimeters less than or equal to 40. In this case, we're only going to light 3 of the LEDs. So again, we light up the first 3, leave the pin 4 turned off, basically. Again, delay for 1/2 a second. All right, and then don't forget our curly bracket for this if statement for the end of this statement. All right, so the next section basically is going to be greater than 40 but less than 60. So centimeters is greater than 40, then centimeters less than or equal to 60. Same thing, except we're only going to light 2 of our LEDs now. So 2 LEDs get lit and 2 get turned off. Again, delay for 1/2 a second. Don't forget the curly bracket again for the if statement. The next one is greater than 60 but less than 80, less than or equal to 80 centimeters. All right, so again, we're only going to light 1 LED now. So 1 LED gets high and the rest are low. Again, 1/2 a second delay time. Don't forget the curly brackets. And finally, if it's greater than 80 centimeters, basically, then we're not going to light any LEDs, so we turn them all off, basically. Again, we wait for 1/2 a second before we check again. Don't forget the curly bracket. All right, so now we're going to start coding for the first return function, the microseconds to inches, basically. Again, after our comments here, what we want to do is we want to return the microseconds. So we're going to take the value here that we get for microseconds. That's our duration variable that we sent here. Again, it's a long variable. So and what we're going to be returning here for this return function is also going to be a long. So it's going to be in a decimal number. So what we're going to do is, so according to our data sheet for the ping sensor, basically there are 73.746 microseconds per inch. In other words, sound travels at 1130 feet per second. So if we do the math, that's about how far it goes. So what we're going to do is we're going to take our microseconds, we're going to divide that by 74 basically, and then we're also going to divide that by 2 to get the actual distance to the object, because again, we're dividing by 2 because it's going to go there and then come back. So we want to kind of only want half that distance. We don't want the going to and coming back distance. All right, because the duration is going to be the going to and coming back time, basically. All right, so that's what we return. We send that back to our wherever we call this function from. In this case, it gives us inches. All right, and again, don't forget our curly bracket at the end here. So we need a curly bracket here, and then we need another curly bracket at the end to close up this function. All right, same thing for centimeters, except in this case, the speed of sound for the metric speed of sound is 340 meters per second, which basically works out to be about 20 microseconds per centimeter. So we're going to divide by 29 and then also divide by 2 to get us the distance that how many centimeters basically is kind of away from the sensor. Again, don't forget to put in the curly bracket for our return function. And that should be it. So again, now we're going to run it and see if it does what we expect, and see what happens. Okay, so again, we've gone and put in the code. So here's our constant variables. Here's our setup command. We're setting up the serial monitor. Here's our output, our pin mode set to output. We're setting some variables for duration, inches, and centimeters. We're sending out a ping basically to be reflected back off of something. And then we're basically we're listening for that ping to come back and giving that taking how long that takes, the duration. Again, that gives us how many inches and centimeters. We're going to put all that information into the serial monitor so we can double check there, so we can monitor there. Okay. Then we're also going to basically light up the LEDs based on how far away it is. Again, the closer it is, the more LEDs get lit. So, and then different distances there. We're using 2 return functions, one for inches and one for centimeters, and basing that information on the duration, how long it takes the signal to return. We're doing a little calculation, which will then send that back to our thing. All right, so let's turn on our serial monitor. Let's go ahead and get started. Now, the way this one works is if you click on the ping Arduino thing here. Let me scroll this down a little bit. So you can see right now it's about 44 inches or about 113 centimeters, but I can bring in my object a little closer so you can kind of see how there. And again, if it gets real close, of course, we light all the 4 of our LEDs, and that's pretty much what we're expecting. If our centimeters, if the centimeters is less than, what did we say, 20 centimeters, I think. So let's double check here. Yeah, so if it's less than 20 centimeters, it's going to light all of them. So if we put this out to, say, about 35 centimeters, okay, then all right, we got 3 LEDs lit up, and that's about what we're expecting, kind of in the 30 range there. Again, if it gets out to about 40, then we're going to see 2, and again, we get out a little bit further to 50. Whoops, too far there. Going back here. All right, so about 50, we see 2, then 60 is about 1, 70 in this case, 70 centimeters, and then if it's more than 80 centimeters, basically, then we don't have any lit. So basically, there we go. We got it working. We can kind of check on our serial monitor, see how that's working. But basically, yeah, all the code is working what we expect.